All right, 8.3 video notes. Finally, we are starting to learn a little bit about some trigonometry. Starting off pretty relaxed today. Identifying the three trigonometric, sorry about that, ratios, and Sohcahtoa. Kind of sounds like a summer camp you may have went to, but it's a little mnemonic device so that we can memorize the relationships or the ratios of sine, cosine, and tangent. So let's go ahead and let's just dive right into this. All right, so first of all, what is trigonometry? So trigonometry is basically the study of triangles. So trig is only used for triangles. We're really not going to do anything with any other shapes, but anything with three sides, we can use these ratios. We're going to start off, the main part of chapter 8 is right triangles. So everything I'm going to teach you right now is going to involve right triangles. We will later on in the chapter do law of sines and law of cosines for triangles that are acute or obtuse. But right now everything is going to be a right triangle. So the Sohcahtoa business, what does this represent? Well, the ratios in a triangle are related to the sine, cosine, and tangent. And so I'm going to start off with the first one, the sine, which is S-I-N-E. Now on your calculator, you're going to see it as S-I-N, but we still call that the sine. It's not sin, it's sine. So if you notice right here, I have it as S-I-N. So the sine of, and this little zero with a line through it, is theta. It's a Greek letter, and it's often used to represent the reference angle in a right triangle. So, you know, if you have some right triangle, something like this, and there's my right angle. If I put theta in right here, theta you can almost think of as like an X. You know, theta is basically the same as like X degrees. We don't know how many degrees it is. But it's really your point of view, not point of, I was going to say it's a reference angle, but it is a point of view. All right, point of view, also known as a reference angle. Okay, because if this is my reference angle right here, and I kind of like to think of it as a guy, you know, I have a person standing on this angle. Well, there's three different sides here. The side across from the 90 is always called the hypotenuse. So this side right over here, I'm going to do these sides in purple. This side right here is always the hypotenuse. Okay, and the hypotenuse is easy to identify because it's across from the 90 degrees. Now, we have two legs left. Depending on where I'm standing, the leg opposite me or across from me, that's called, you know, the opposite leg. And the leg right next to me that I'm standing on, this is the adjacent leg. Now that changes if my guy or my man jumps to another corner. I'm not going to write all of them out, but if the guy were to jump up here, now my opposite and my adjacent would switch. The hypotenuse is always going to stay the same. It's always across from the 90. But I just want you to know that theta represents the reference angle or the point of view of where your guy or your girl is standing. Okay, now here are the ratios. The sine is represented by the opposite leg over the hypotenuse. So we get this mnemonic device, sine, opposite, hypotenuse. That's where we get the SO from. The cosine is the adjacent divided by or on top of the hypotenuse. And then the tangent is the ratio of the opposite to the adjacent. All right. And every triangle, no matter how big or how small, with certain degrees, has these relationships, has these ratios that kind of stay fixed or stay the same. So let's kind of jump down and let's get into a few examples, and maybe this will make a little bit more sense. So I go down here in example 1, and what they're asking me to do is they want me to find the ratios, both as fractions and as decimals, and we're always going to do these decimals to 3 places, okay, which is tens, hundreds, thousands. So that would be the thousandth place. We're always going to do that to 3 places. So let's take a peek here. So if we want to find out the sine of A, all right, my reference angle is A. So this is the reference angle. So I'm going to put my guy and I'm going to stand on A. Now step 2 is I label the sides of the triangle. Okay, so the hypotenuse is always across from the 90, so this is the hypotenuse. The opposite is across from me, so I look across the triangle, right here, this is the opposite leg, and the adjacent leg is the one that's left that's right beside me. Okay, and if I were to position my guy, some people actually like to do it like this. They actually put their guy, and then they stand one leg on each side, and then I say, all right, the opposite is the leg you're not standing on. So if you notice, I am standing on this adjacent leg down here. But I usually don't put my guy that close, but you can. All right, so let's now go through the ratios. Well, we're keeping in mind Sohcahtoa. You really need to memorize this. If you memorize that, you're in pretty good shape. Sohcahtoa. So the sine of A should be the opposite leg, which is 5, over the hypotenuse, because opposite over hypotenuse. The hypotenuse is 13. So there's the fraction, and then we need to change this thing into a decimal, and I can do that just by punching in my calculator, 5 divided by 13. There's also an F to D key on your calculator. I think you have to hit the second function, but you could do that as well, but I think it's faster just to do 5 divided by 13. And we get 0.3846, which is going to be 0.385 when we round it off. Now the cosine of A, well, that's CAH. So that's the adjacent, which is 12, over the hypotenuse, which is 13. And when I look at that decimal, 12 divided by 13, I get 0.923. And it's followed by a 0, so I can just leave it as 0.923. Now the tangent when standing on A, tangent is opposite over adjacent, TOA. So opposite leg over adjacent leg, which is 5/12. 5 divided by 12 is 0.416 repeating. So 0.41666666. So I'm going to call that 7. I'm going to round it off there. So every single triangle out there that is in ratios with 5, 12, 13 has these fractions or these values. And I'm actually going to teach you later on how to work backwards and figure out what angle made that. Like we can actually now calculate angle A using some keys on our calculator to do the inverse sine, and we can work backwards and find it. Alright, now for the second column over here, the game changes slightly. I'll do these in purple. Now our reference angle, or our point of view, is at C. So I'm going to erase my guy. And my adjacent and my opposite and these dudes are going to change. So let's go ahead and let's put our man on C. So we're standing up here on C. And the hypotenuse is always, I shouldn't have erased that because the hypotenuse is always the hypotenuse. It's always across from the 90-degree angle. But now the opposite leg is going to be the 12 and the adjacent leg is going to be the 5. So they switched because my point of view or my reference switched. So now we go through these again. I'm going to go a little quicker on these ones. Sine is opposite, which is 12, over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. And then I can go back in and I can find these 3 decimals, which I'm going to do pretty quickly. 12/13 I don't have to do because I already have it over here. It's 0.923. 5/13 I already have right here. 0.385. And the tangent is going to be different. That's 12 divided by 5, which is 2.4. Now, if you notice, that's always going to happen. Your sine of one reference angle is going to be equal to the cosine of the other one, because I've changed who opposite and who adjacent is. And the same thing going the other way. The cosine of A is going to be the same as sine of C. That's a pattern that will always hold true. Alright, so basically all we've done, we haven't solved anything, but you've just found the ratios for this particular triangle from all the different sides. So let's move down and let's try another one. If you want to pause right now, pause the video, see if you can do this one on your own. Give it a shot and then see if you can check it out with mine. Now you always want to reduce the fraction. Always reduce the fraction because standardized tests are going to have these reduced. Alright, so I'm going to get after this one. Put my guy up here. My reference is A for all these ones over here on the left. So we'll do these guys first. So labeling my picture, I have hypotenuse, I have opposite, and I have the one next to me is the adjacent. So then I got to remember Sohcahtoa. And this will become second nature here in another 2 or 3 days. But sine is opposite over hypotenuse, so that's 36 over 45, which that reduces down, and you should know how to do that on your calculator by now or by hand, but 9 goes into both of those, so this reduces down to 4/5 or 0.800 because I want to keep 3 decimal places. Alright, we still want to go 3 places. If I don't tell you, it's always 3 places. I may forget to put directions on a homework or something like that, or a homework quiz. Alright, cosine of A is adjacent over hypotenuse, which 9 goes into both of those numbers. That is 3/4 or 0.750. And then finally the tangent is the opposite over adjacent. Opposite over adjacent, which 9 goes into both of those. 4 and 3. And I just screwed up, so go back and check me here. This is not 3/4. This is 3/5, which is 0.600. This is 1.333. Alright, so I think that looks a little bit better. Now we got to change the picture up a little bit. I'll do these in red. Now we change the picture because our reference angle changed. Alright, our reference angle now changed to C. So I got to put my guy over here at C. I label my picture hypotenuse, opposite, adjacent. Sometimes I just use HO and A. After you start doing a few problems, you may want to write a little bit less. So the sine of C should be opposite over hypotenuse, 27 over 45. But wait a minute, we've already done that. That's the same as this one. So I'm just going to copy that down. 3/5, 0.600. The cosine is adjacent over hypotenuse, which we already did up here. That's 4 over 5, which is 0.800. And then we have the tangent, which is the opposite over adjacent. We have not did this one yet. This one is 3/4, which this is the one I accidentally did earlier, which should be 0.750. So we found the ratios for all of those values. Now, example 3, I want to move to the calculator, and actually when we get into class, we can also use a chart. The hard part is the chart you may not always have on you, but hopefully you'll always have access to a calculator. And even the iPhones and most smartphones have a calculator built in that has the trig functions. So we're going to be able to use this. So let's go to our calculator, and let's just make sure that we can find these keys because we're going to need them later. So let's go down. In order to solve triangles and find out angles or find out sides, we need to have all of these already worked out in the calculator. So the tangent of 70, let's just see let's just see what the tangent of 70 degrees is. So in my calculator, first thing is, whatever type of calculator you have, check the mode button and make sure that you are in degree mode. A lot of times it'll say DEG. Do not use radian mode or RAD. Radian mode is a different unit besides degrees that will give you totally different values. Alright, so we want to make sure that we are in degree mode. This is the mode we're going to be using. So let me just check the mode on my calculator. Make sure I'm right. And I am. So the tangent of 70 degrees, when I punch this in my calculator, I get 2.747, and then the next digit would tell me to keep it a 7. So if you're in degree mode, that's what you should get. If you are not in degree mode, you'll get something else that's kind of radically different. Let me just see if I can change it. I'll change mine to radian and just show you what the wrong answer would be. Tangent of 70 is going to be 1. If you get 1.2219, or it would be that means you're in radian mode, and that's the wrong answer. So you need to change your mode. Otherwise, everything is going to be wrong. And believe me, I have had kids that take the final chapter test, the calculator's in the wrong mode, and everything is wrong. Now, I usually let them redo it, but don't be that guy. Don't be that person. So let me be careful. I'm going to switch mine back to degree mode. And boom. All right. Now, one other thing on calculators. My calculator that I issued to you guys is the TI-30 X Roman numeral 2S. If you're using this one, these are the ones I issued this year. These ones are nice because you should have a sine, a cosine, and a tangent key right on the calculator. All right, it should be right on there. Now, if you don't, if you've borrowed some from up in the front of my classroom that were just kind of the freebies up there in the bin, these ones are called the TI-34 multi-view. I don't like these near as well because this calculator, you are going to have to do a little extra stuff here. If you look at the pi key, right above the pi key is the word trig. Okay, T-R-I-G. And so in order for you to find sine, cosine, and tangent, you're going to have to hit the second button, which is in the upper left-hand corner of your calculator. You're going to have to hit second pi key. And when you do that, so I go second pi key, you're going to see a menu that's going to have number 1 will be sine, number 2 will be cosine, and number 3 will be tangent. And then you're going to have to select which one you want. You're going to have to push 1, 2, or 3, or use the arrows to go down. Much more tedious. So again, if you're using a calculator, use the one that I checked out to you. If you didn't get one from me that was been checked out, come get one from me. All right, because it's just a lot of extra keystrokes that are unnecessary. So let's go ahead and let's fly through this, and let me just finish this up. Cosine of 70 should be 0.342. Cosine of 14 should be 0.970. Sine of 84 should be 0.9945, so it would actually round up to 5. Moving over to the next column, sine of 7 is 0.122 when I round it. Tangent of 59 is 1.6642, so I'll leave the 4 alone. The sine of 90 is 1, and the tangent of 47 is 1.072. 1.072. All right, so hopefully you're able to put these ratios in the calculator. And let me just explain what these mean. Let me just kind of show you, like, I'll just highlight one of these. Like, why is the sine of 84 degrees 0.995? Like, who the heck why does your calculator have that programmed into it? Here's what it actually means. what it actually means is if I have a triangle, okay, with an angle of 84 degrees, which is really, really, really steep, and actually maybe, I don't know, this one's going to be, I guess I'll still use it, kind of make it longer. If I have a little triangle like this, and I'm trying to draw it to where, you know, this is 84 degrees, close to 90. All right, what that means is that the sine of 84, remember sine is opposite over hypotenuse, Sohcahtoa. It means that in any triangle that the degrees are 84, which would make this one over here pretty small, it'd make it 6. Any triangle, whether how big or how small, whether I blow that up or shrink it, all triangles that are 84 degrees and 6 degrees, they kind of look like a 60 down there, but it's actually 6 degrees. It means the ratio between this, so I put my guy here at 84 degrees. It means this opposite leg divided by the hypotenuse is always going to be 0.995, which means this opposite leg is almost the same size as the hypotenuse, just a little bit smaller. So when I do this opposite leg divided by, either whether I do it like this or whether I write it out, opposite divided by hypotenuse, it's going to come out to be 0.995. So somebody's already went through and measured and calculated all these triangles for every single combination of degrees, you know, 84 and 6, 83 and 7, 82 and 8, and they've calculated the ratios for all three sides, and they've been programmed into your calculator. So that's what these numbers represent. They represent the division that somebody has done between the sides in this specific triangle, regardless of size. You know, it doesn't matter if it's a bigger or smaller version, they're always going to have those same ratios. All right, that's enough for today for the introduction. This should be enough to get you rolling on 8.3. There's a lot more in store, so hold on tight. See ya.